Hey there, 5th graders. This is Mr. Bunn again for another math lesson, and today I'm going to discuss lesson 17, which is I can draw parallelograms to clarify their attributes and define parallelograms based on those attributes. It's going to be a little bit shorter of a lesson today, and after this video, I'd like you to hop back onto IXL Math today, and I'll give you the assignments that I'd like you to look over, and I'd also like you to go on Zern for quite a bit today. Now, just to review what we did with lesson 16, I have the notes that I took. We looked over various vocabulary that you need to know going forward, and just understanding what parallel means, and that's lines opposite of each other going in the same direction and will never cross paths. We have quadrilaterals, which are simply just four-sided objects, four-sided figures. And we have a trapezoid, and that's a quadrilateral which at least one pair of opposite sides are parallel. So I'm going to draw for you a quadrilateral. It's going to have four sides. And there's a quadrilateral. Four different sides, and there you go. Now, this quadrilateral is not a trapezoid because you'd have to have two lines opposite of each other that will always go in the same direction and never cross paths. If I kept going with this side length right here with dashed lines, and this one, you can see they cross paths. They are not parallel. Same thing goes for this side and this side. They would continue onward, and they would of course cross paths. They are not parallel. Let's draw a trapezoid, and an example of a trapezoid, I will draw a line here and then say a line right there. They are parallel. These arrows signify that. And then I'll just go ahead and connect like so. This is a trapezoid. Has at least one pair of opposite sides that are parallel. Now, parallelograms, which I spoke a little bit about in lesson 16, they are it's a figure that it's a 2D object that has opposite side lengths that are parallel. So I'm going to draw a line here, and I say a line here, and I'm going to signify that with one arrow for both these lines that they are going in the same direction and will never touch. And I'm going to draw, let's see here, I'm going to draw a line connecting here, but I'm also going to make that same line over here, trying to draw it where it looks like they are going in the same direction. I'm going to draw two lines here, two arrows, signifying that they are in fact parallel with each other. And I just had to connect that little side right there. So this is a parallelogram. You have these sides are parallel, and then these sides are parallel. Now, parallelograms are also trapezoids, okay? And there is a, let's take a look at your green workbook. If you take a look at should be page 249, you can see that it has a diagram for you, and it gives you a great indication of these figures. Now, this basically means that quadrilaterals are four-sided objects, and all quadrilaterals encompass this. All right, so these objects are all quadrilaterals. They fit inside that definition of a quadrilateral. Now, parallelograms, they are always going to be trapezoids, but not every trapezoid is going to be a parallelogram. You could have a trapezoid that has only one pair of opposite sides that are parallel. Parallelograms need to have two. And all parallelograms are quadrilaterals as well, and you can see here all trapezoids are going to be quadrilaterals, but as I drew the first figure on my whiteboard, not all quadrilaterals need to be trapezoids, because you might have, all you need is a four-sided figure, but you don't need to have any parallel sides. Now, one thing to note about parallelograms, and I'm going to draw a famous parallelogram. A lot of math books will have a parallelogram that just looks like this. It's important to know the angle measures, and we don't have, if you have a protractor at home, it's a great way to measure the angles here, but it's important to know that we don't have that, so I'm just going to show it to you on this video. if we need to know acute, obtuse, and of course right angles, what they mean. And you learned this in 4th grade, and we talked about it earlier in the school year. Acute angles are less than 90 degrees. Obtuse angles are greater than 90 degrees, but also less than 180. If you have an angle that's 180 degrees, that's just simply a straight line. And then, of course, a right angle is exactly 90 degrees. And now when you're drawing a figure, or you see a figure and they have that little box like so, this means 90 degrees. When you draw a little curve, like a little semicircle there, that means that the angle measure is going to be something other than 90 degrees. That's important to know. Now, one thing I'm going to explain to you that I think is very important to know, and I might be getting ahead of myself, but that's okay. If you have an acute angle here, say of the measure of 60 degrees, when you're dealing with parallelograms, the opposite angle measure of this one is going to be the exact same angle measure. Just know that. And then all the angle measures inside this figure, inside this quadrilateral, is going to equal 360 degrees when we add them all up. So when you're given this piece of information, you can figure out the missing angle measures. And when you're dealing with parallelograms, if the opposite angle measures are the same, it's important to know that the adjacent ones, adjacent means right next to, they're going to equal 180 degrees. So if you take 180 degrees and subtract 60, you would get 120 degrees. This angle measure is going to be 120 degrees. Now the opposite angle will end up being 120 degrees also. And when you're dealing with the side lengths of a parallelogram, it's important to know that whatever this length is, say it's 6 centimeters, the opposite one is going to be exactly the same as well, just like a rectangle. And if this was, say, 3 centimeters from here to here, this is also going to be 3 centimeters. Now, going back to telling you that all the angle measures equal 360, if you add all of these angle measures up, so 120 plus 120 plus 60 plus 60, you end up with 12, 4, 16, and 3, so it actually equals 360 degrees. So that's important to note with quadrilaterals. All the angle measures are going to equal to 360 degrees. If you know what a 360 is, it's when you're standing upright and you spin around one time and you're all of a sudden looking back in the same direction where you started from. That's a 360 degrees. You can go ahead and do some 360 twirls around your home. Your teacher said so. So this is information that you need to know for today for parallelograms. It's also very important to note that if you are looking at a rectangle, this is a parallelogram because these side lengths are parallel and these sides are parallel as well. And just to know about a rectangle, they all have 90 degrees. And if you added 90 degrees 4 times or just did 90 times 4, you would also get 360 degrees in terms of their angle measure. That for today, it's just my short little spiel on parallelograms. And go back to your notes if you need it today. What I'd like you to do is go back onto IXL Math. And if you have not done BB.5, .6, and .7, I'd like you to do that. That was the assignment from last Friday. But I'd also like you to do BB.8 today. And then after that, go on to Zern. BB.8 is all about parallelograms. So there'll be some questions in there regarding, side measures. There'll be questions possibly asking you about angle measure. Just take this information that I gave you. If you need to copy it down for some notes, I would definitely do that. But here's your assignment for what I'd like you to do after this. And this is all the information you need for today's lesson on parallelograms. You'll probably have a little review on trapezoids and on quadrilaterals as well. Just know, and I'm going to say this repetitively because it's important to know, all parallelograms are trapezoids and they are all quadrilaterals. All trapezoids are quadrilaterals. Some trapezoids are parallelograms, but not all trapezoids are going to be a parallelogram. And it's important to know that you can have quadrilaterals that aren't trapezoids of parallelograms, but you certainly, of course, can have a quadrilateral, a four-sided figure that is a trapezoid and a parallelogram. So that's important to know. So take a look at this template that should be page 249 in your green workbook. That is it for today. Our objective was I can draw parallelograms to clarify their attributes and define parallelograms based on those attributes, these characteristics. When I say attribute, I am meaning the characteristics of this type of figure. All right, that's your math lesson for Monday. This is Mr. Bunt signing off. Have fun with your math work today, kids. I'll talk to you soon.